Okay, everybody, I think we're ready to begin. I first of all want to thank everybody for joining us today. I think it's going to be a really very interesting, very timely discussion for us. I'm Jay Myers. I'm the CEO of Next Generation Manufacturing Canada, and as everybody knows, our objective is building world-leading advanced manufacturing capabilities in Canada. In doing that, we're supporting projects at the cutting edge of Industry 4.0, but we're also looking at how do we enable better deployment of advanced technologies in manufacturing operations across Canada. May not be leading edge applications, but the adoption, the deployment, the profitable deployment of technologies, and of course the business requirements, the skills requirements that on the part of companies in order to successfully deploy technologies is a key part of what we're aiming to do in supporting the sector as a whole. So I'm really glad to be joined today by a fantastic panel of experts. I'm going to introduce them in a minute, and our guest speaker. I want to thank first of all, Salesforce for their sponsorship for today's session. I'll maybe say a few things, I guess, in terms of some of the overall trends that we've been seeing. We've been speaking about Industry 4.0 for some time, and many companies today, many manufacturers are collecting data, maybe from different types of equipment, from different systems, from different operating systems, but collecting data nevertheless. They're connecting systems, they're connecting with each other as well, connecting across factories. I think we're well into Industry 4.0, but we really haven't seen what can be delivered yet, especially in terms of better systems of identifying what data is important to understand, what data is important to collect, what data is important to analyze in order to achieve better performance improvement, how to begin to predict outcomes and in processes, and then alternatively, or maybe sometime down the road, how to build in greater autonomy, not only in processes, but in products as well. And to some extent, we're already seeing that in many consumer products today. So here to tell us where we're going, where some of the opportunities are, where some of the challenges are, and maybe giving some really great advice along the way in terms of what it takes for successful deployment of smart factory technologies to improve digital and production operations. We've got a great team here. First of all, let me pass it over to Peter Coffey. Peter is with Salesforce, our sponsor for today's event, and I can tell you from our discussions previously with Peter, great perspective on the industry as a whole, but particularly on some of the opportunities that manufacturers have, and also some best practices in terms of successful deployment and implementation practices. So, Peter, over to you.
Thank you very much, Jay. And if someone can confirm for me that the slides are showing.
They are.
Excellent. It's so important to emphasize what you've just been saying, that we need to go beyond traditional notions of mere efficiency. Peter Drucker, of course, has famously said there is no greater sin than doing the wrong thing better. And cutting the cost and improving the speed of going in the wrong direction is not a win, even if your performance indicators may tell you you're doing a great job. My team at Salesforce occasionally uses the comment that we don't predict, we reveal. I'm not here to show you any vision of the future here so much as I am to illuminate where we are and what the current states of change are, so that we can kind of do the math in our heads and say, these are really not predictions we're making. This is a future that's already unfolding as we speak. And in fact, the World Economic Forum has been very good about illuminating some of these specific ideas. This is a little bit of an eye chart. It's got an awful lot of things that may not seem to be in the wheelhouse of the group that's with us today. So let me focus on two of them. The evident issues that have been illuminated during the last 2 years of pandemic, but that really have a lot of origin and likely continuation in things that are happening globally of demand uncertainty and disruption. And the already before the pandemic, things that were underway in terms of generational changes, demographic change. Demographic change is a perfect example where you're not really making a prediction. If I know how many 20-year-olds are graduating from college today, I have a pretty good handle on how many 30-year-old experienced workers I'm going to have 10 years from now. It's really just doing the math. So these two combinations of the external environment around manufacturing and the talent pools available and the opportunities and challenges that they represent to manufacturers, I really feel are two of the things that deserve most of the attention that I'll be trying to share with you now. McKinsey has been very clear that we shouldn't think of the last 2 years as in any way exceptional, except for the particular cause of the disruption being a novel pathogen, that by any measure, and I mean measure very literally, the IMF World Uncertainty Index, Federal Reserve Board geopolitical risk, frequency and intensity of cyber attacks, natural disasters driven by climate change. And I do not want to get into a discussion of whose fault climate change is. It is merely a visible reality that these things are happening. This level of rising volatility in the environment, the Army War College in the US uses the term VUCA for volatility, uncertainty, complexity, and ambiguity. These four things drive a need for discussion. And again, McKinsey has observed, we spent the decade pre-pandemic with a general ethos that the idea was to optimize your supply chain for minimum cost. We built just-in-time supply chains that spanned oceans. And when one boat got stuck in the Suez Canal, some of the fragility and brittleness of the resulting highly optimized systems was certainly cast into a bright light. The idea, as again, McKinsey suggests, that you should anticipate a significant multi-month supply chain disruption roughly every 4 years and build systems with the resilience to handle that is somewhat different from what has been being trumpeted in the magazines and taught in the business schools during the last several years or even decades. And the human component of this really can't be overemphasized. The rapidity of platform and process change means that today a newly graduated engineer needs to be spending equivalent of hours or even weeks per year on ongoing study merely to stay current in their field. The idea that your college degree was essentially a capital asset that you would depreciate over the life of your career is doubly mistaken because one, the skills are changing more quickly, and two, the length of the career is itself greater. So that's a compounding issue. 70% of employers believe that employees need continuous education and training. And I'm not talking about taking people off the line for 1 week a year to sit in a classroom being told things, maybe 80 or 90% of which they already know, or maybe even know better than the instructor, and the rest of which they don't yet know why they need it. We need to introduce education and training in line into the workplace that as people realize they have a need, there's a micro moment that's available, they can be supported by technology that's literally in their hands. And upskilling needs to be a continuous process, a continuous flow, and not a batch process that's done at high cost with low effectiveness. Another really key observation is that when employees feel that they are a investment by their employer, that they are being upskilled and made more valuable over time, their likelihood of remaining with an employer significantly rises. And today, keeping the talent you've got is increasingly a challenge. The mobility of the workforce, their ability to discover other opportunities, their ability to take that job somewhere else because they can do it remotely. All of these are really key. As we look at opportunities like natural resources in the more remote parts of North America, we realize that a lot of these jobs will be done by telepresence, by people operating remotely call them robots if you will, by operating machinery, they don't need to be on site to operate. Their ability to change employment is going to be more frictionless than it's ever been before. And yet my friend Paul Dougherty over at Accenture has said half of companies, while agreeing that their people need more skills, only 3% are increasing training investments. And that's a gap. That's just enormous. We know why people aren't increasing training investments, because training looks like a pure cost that takes people off the production process. The idea that we can infuse continuous upskilling, continuous availability of new knowledge directly into the workday is a novel opportunity, and one that I think is probably not being fully pursued by most manufacturers who don't really appreciate that this is a reality. This is a future that's now. The resources are in fact at hand, and I'll show you what I literally mean by at hand. The convergence of IT and operations technology, the convergence of things that used to be considered back office or Salesforce tools, and of course the company's name literally is Salesforce, but the idea that these technologies can become relevant throughout the production process, that the cycle can be in fact a closed loop, where instead of production creating a product that is sold by sales and supported by service, well, now this is a continuous circle where the product becomes a channel for delivering an ongoing stream of services, and the consumption of those services becomes input to the next generation of product design. This is a holistic integration among the units of the manufacturer that replaces what was previously much more of a pipeline. We use the word pipeline a lot in business up until now for sequential, handoff to handoff to handoff. It's really got to be much more of an integrated and continuing operation from now on. Another key point is that this is no longer monolithic effort by a single major firm to build and sell and support a product. This notion that we're going to be building products that are kernels of ongoing delivery of services, a simple example would be something like the iPod, which when it was first introduced, entered a marketplace that had many companies making digital music players as products, and they left it to the user to go out and find the music to put on there. Sony thought it had an edge because it owned a large content library, which it thought of as a proprietary feature of its digital music players. And the radical notion of Apple breaking open the device to make it just the kernel of the iPod plus iTunes ecosystem and pulling in all of the existing content providers in a way that had really never been attempted before, let alone achieved. This idea that you build an ecosystem that redefines a market, and I do mean literally redefines, because 3 years after the first introduction of the iPod, the word podcast was introduced by the Oxford English Dictionary, or I should say recognized by the Oxford English Dictionary. Simplifying deployment is key. It can't take 2 years to roll out a solution to a problem that's probably not going to be recognizable as the one that was originally envisioned at the time that that process began. The idea that we need to move to continuous flow as readily as you upgrade the apps on your phone. Now, and think about that, because only 10 years ago, getting an unscheduled update to a piece of software was on the supply side a confession that someone had made a mistake, and on the consumer side an irritating nuisance that was going to get in the way. And now we've made that essentially an ongoing cadence of continuous improvement. Bringing that into the industrial environment is still a work in progress, but it clearly is achievable if once we realize that that is the definition of success. Another key idea is not to have massively centralized systems, but to move as much of the intelligence to the edge as possible. One of my favorite examples is that when a Tesla is driving down the street and its machine vision sees a pothole and dodges around it, well, okay, that's an impressive little piece of micro AI. What's less visible, but in many ways much more interesting, is that the next Tesla coming down the street doesn't need to see the pothole, it already knows about it. And this has been described by people I know who are intimately involved with 5G as the critical understanding of why 5G is not 4G made faster. 5G is a distribution of control, seeing what's being built as a computing fabric that moves data when it needs to do that, instead of a dumb network that has everything collecting the data in the middle. The reason this really matters in industry and manufacturing environments is that we all understand that having dozens, hundreds, thousands of devices telling the center every 10th of a second, yes, everything is still fine. Having vast quantities of, yeah, everything is still working fine, traffic, that does not scale. What we need to have is systems that can be relied upon to notify the center when something interesting is happening, to have information shared out to the edge so that local decision-making can be made. And an example I often offer is this. If you've ever touched a hot object and jerked your finger away and then noticed that your finger hurts, you've already seen this happen. There's that little local loop that goes from fingertip to spinal cord and back, the so-called reflex arc. And then after the finger is out of trouble, a much slower signal can propagate its way up to your brain and you can say, ouch. And then a few critical fractions of a second later, another slower piece of your brain can say, that should never be that hot. I'm going to file a trouble ticket. Just in that one moment, you've seen 3 different levels of network interact to do simple things quickly without involving the center at all, to get the problem under control, but then to have an opportunity to add cognitive value and centralized consideration so that you can tell everybody else, whatever you do, don't touch that thing for the next hour. We're working on it. This is just something that happens every day. Well, this is what can happen in factories as well. A tool is not a dumb object anymore. This is something that we worked on with Bosch when they introduced their IoT cloud to say, a hand tool is really the end point of a process. And collecting data off the tool so that you can then do something like say, okay, this tool is running a little bit hot. It's still within tolerance, but it's been getting hotter. We should look at it before it has to be taken out of production. These are ideas that have been around for decades. W. Edwards Deming and statistical process control. If you find that on average, a drill that is used to drill 110 holes begins to drill them out of tolerance, well, you start replacing the drill bits preemptively at the 100th hole. Well, now we can do this in a much more dynamic and intelligent way instead of relying on old static numbers like that, and be able to roll a service case automatically created when the data says it's likely to be needed at some time in the near future. And this is an actual literal tool that you could put in a worker's hand. It's got a barcode scanner in the base. It's got a web browser built in at the top. And when the worker goes up to a workpiece, it scans a QR code and it tells the worker these 4 bolts need to be torqued to this level. They do that operation. Which operator torqued those bolts to correct spec on which workstation, on which day and time is automatically logged, and all sorts of issues of correct recording, of correct performance of operations, quality control issues that we've wrestled with for decades can now be dramatically made less frictional and more accurate. And these are platforms. I was over in Berlin for the launch of this, and we actually did a hackathon for a hand tool. Say, what kind of applications would it be useful to put literally in the worker's hand? Well, people get bored and start making mistakes when they do the same thing over and over again. We can actually have the tool command changes in sequence of operations where they don't change the outcome just to keep the worker engaged. We can gamify these operations. We can let people, see leaderboards for who's maintaining the highest combination of quality and throughput. There's so much opportunity to have the intelligence leave the back office and be diffused throughout the operation so that workers can feel like they are actively engaged in a system that's doing better work. And manufacturers recognize this. 86% of manufacturers believe that smart factory initiatives will be the main driver of competitiveness within the next 5 years. Again, this is a future that's already underway. 83% of them believe it's going to change the way products are made. This is data from a study that Deloitte contributed substantially to. And they expect that they're going to be spending the money to do this because this is not an expense to be minimized. This is an investment to be pursued for the leverage it brings in taking historically razor-thin profit margins and bringing the modern factory up to, if not Apple level profit margins, then certainly much more profitable provisions of value-adding services over the lifetime of an evolving product. So the objectives for this in digital production, operational resilience, growth with automation, enabling the visibility. I sometimes say digital transformation is a very vague phrase, but we can unpack into 4 very specific ideas: connection, so you can get the data; awareness, that you have some notion of what the data should mean for you; S, for smartness, that is to say, using machine learning and other tools to make this scalable; and finally, trust, where people have to rely on the data and be prepared to take action based on it. So connected, aware, smart, and trusted, CAST. It's a simple acronym for what makes digital transformation actually happen, and it creates new value streams, and this is key. 80% of the money that's spent on initiatives called digital transformation has been estimated to really be targeted at cost reduction and streamlining of existing operations. But Jeannie Ross at MIT has said the point is that you have to take the technology and create new value and not merely cut the cost of the kind of value you delivered before. Because otherwise you're trying to succeed in the digital world with a pre-digital value proposition. Manufacturers understand this. They think the returns are going to be there. They are going to make these investments. Among the things we've learned how to do during the last few years is how to create a digital headquarters to make it possible for more and more people to contribute from anywhere, for more people to do their work remotely, or to do it with more flexible work hours. And there are any number of ways in which we can do this. I want you to think about one thing that's probably familiar to all of you. Try to cast your mind back several decades before we had spreadsheets. And when, if you needed to do number crunching at scale, you had to go down the hall and talk to someone who probably wrote COBOL. The democratization of access to that calculation power allowed people on many desks and in many mobile environments to start asking and answering questions about math. And now we can start asking and answering questions about a much richer variety of things, including production rates, quality, materials specifications, and so on. And this is something that my friend Dion Hinchcliffe has observed, that we need to move from the old notion that workplace automation tells people what to do, to remind ourselves of how transformational it has been when people have tools put in their hands that let them do more, that let them use what they know from frontline knowledge and be scalable and visible and making contributions that really get them excited and make them want to stay with you longer and share what they've learned. Interestingly, our own research at Salesforce has found that people don't fear automation when they are the ones creating it. When someone says, okay, I've done this same thing 5 times today. If I can find a way in 30 seconds to make that an automatic process, I don't have to think about that again. I can build a little automation on the spot. You do it when you do a spreadsheet formula. Well, now we can do this in tools like Slack and other workflow environments, so that an automation is created as readily as learning a new way of tying your shoes. AI plays such an important role in this, and so often AI is feared by people as something that's going to replace them, or overestimated by people as something that's going to give them things that candidly really still only exist in movies. But this is an example that I recently ran across. The complexity of the board game of Go is legendary, and it's been characterized as having a so-called game tree complexity of about 170, which is a pretty big number. The game tree complexity of sailing an America's Cup yacht is about 3,000. It's far more complicated. And to train the crews, the elite competitive sailing crews, they built a simulator with some machine learning components to it so that the sailors could sail against the simulator and practice some of the tactics and gambits that are used in competitive sailing. And something happened. The simulator started generating original strategies, and the sailors would look at that and say, hey, that's kind of cool. We never did that. And they started studying the simulator for insights into new competitive strategy. This interplay between what people do well and what machines do faster, and what machines do without preconceived biases about what they think they know doesn't work, this is a different way of thinking about what the AI we actually do have. This is not fantasy stuff. This is stuff that can be deployed now, is being deployed now. And the idea that we can introduce this into real world environments, there's nothing much more real world than being out there on an America's Cup yacht. That's the real world right in your face. I think this is really exciting, and it's a different way of thinking about what AI can do. We want to be contributors to this, and I'm looking forward to the discussion with the rest of the group here. I think people think, because after all, our company name is Salesforce, they think that that's what we're there to support. The idea that this is really about moving data, putting verbs in there as well as nouns, capitalizing on the power to build ecosystems, and the ecosystems that we build with many other companies, like I've already mentioned Bosch, for example, getting the intelligence out there literally in the hands of the production worker and into the distribution and supply chains, really dealing with that world that McKinsey is showing us we will be seeing of high challenge, high volatility, growing uncertainty. This is an opportunity that's right here, and the tools are literally at hand to do things with it. And I'm so pleased to have the chance to discuss these things with the rest of the group that's here today. And I thank everyone involved in making that available to us for what's about to come. Thank you for the chance to be with you.
That's super, Peter. Thank you. I think your focus on getting the information, the intelligence to workers so that they can do their job more and better is really key. As well as this is about making better decisions and better, faster decisions, more highly qualified decisions, and even better prediction. As you say, not only to improve productivity and improve efficiency, but to drive more value as well. And it's really connecting that to those business objectives that is really, really key. So thank you very much for that presentation, and thank you also for joining our panel. So Peter is the Vice President of Strategic Research at Salesforce, and he's going to be joined by three good friends of mine: Peng Cau, who is Vice President at ATS; Paul Boris, who's the President and COO of Premo; and Craig Holden, who's the CEO of Penivo. And Penivo is a company that we've had the pleasure of supporting in implementing some very, very innovative systems optimization tools in agri-food. So I'm going to turn it over to Sean now to moderate our panel, and thank you all for participating. Looking forward to the discussion.
Great. So thank you very much, Jason. And as we get everybody up on the screen, so I am going to disappear, turn my camera off, because this is about the panel. But I thought I would just make sure we take a couple seconds here first. What we're going to do, for those of you joining us, the panel discussion is going to go on till about 2:15. During that time, I'm going to be monitoring the Q&A box, which you should see at the bottom of your screen. If you have questions, please insert them there. At that time, at about 2:15, when I ask the last question here of the panel, I'm going to turn it over and I'm going to ask your questions of our panel. So again, use that Q&A box as we go forward to make sure. And if we don't get to your question, we're going to capture those questions and share them with our panelists so we can make sure we can get a response back to you. Okay, so the Q&A panel, I'll be monitoring that. And with that said, I'm going to turn my camera off. So it's just a panel that's highlighted, and I'm going to start. So let me get into this here. You'll still be able to hear me. It's kind of neat, technology. So I'm going to start with our first question. Now, it's always a kind of trying to figure out who's the best person to ask the first question of, but really I decided to go alphabetically because that was the most fair way to do it. So Craig, you're our first question for the panel. So let me ask you the question. Why is a smart factory important for manufacturing from your perspective?
Well, thanks, Sean, and thanks for having me as well, NGen. So yeah, I thought probably the best way to answer this is just to provide some context first and help with some of the terminology that we're all seeing in this space. So the term smart factory, factory 4.0 and industry 4.0 are all essentially interchangeable terms. So how did we get to industry 4.0? Well, this started with the first industrial revolution, the steam engine. So, and steam being utilized in factories, for example, for like steam-powered looms for weaving fabric. Then Industry 2.0 was the electrification of those manufacturing processes, which was a massive step change in productivity and performance. Following that, Industry 3.0, that's the automation of those systems, the introduction of robotics, PCs and PLCs, ERP systems, just-in-time systems. So again, a spectacular step change in performance and productivity. So now, Industry 4.0, which involves things like the industrial Internet of Things, deploying millions of sensors, implementing AI, machine learning. Ranges, Industry 4.0 ranges from simple digitalization, so taking a single sensor, connecting that to an IoT gateway, sending the data to the cloud and using that data to make decisions in real time and provide information on performance or perhaps some predictive analytics. It ranges from a simple implementation like that to a fully adaptive factory, connecting and linking to the supply chain, having AI robots running around fulfilling orders, etc. And also a big differentiator from Industry 3.0 is the incorporation of customer data in decision making. So with that in mind, why is the smart factory important? So those productivity gains we've seen previously from the various transitions, we're going to see them again. We're going to see improved performance, better debottlenecking, less waste, and less human error. So here's a warning, but also a big opportunity. So imagine going to a steam-driven factory and trying to sell electrification when that started, or going to an automotive plant with manual assembly processes and trying to sell robots and getting pushback. That sounds crazy now, but humans don't like change. Now, Factory 4.0 is here. We're going to see another step change in performance, and Canadian Manufacturing Corps needs to not only embrace Factory 4.0 and Smart Factory, but also lead on it. Thanks.
Great, thanks, Craig. Now, I'm going to ask our other two panelists for their perspective, because this is a pretty broad question. So Peng, do you have anything to add relative to why is Smart Factory important for manufacturing from your perspective?
Sorry, there you go. Yeah, absolutely. I think it all boils down to, like every corporation, we're, making profit, and that means how do you allow your employees to work smarter and more efficient? And to what Craig has just said, the automation aspect, it's up to this point has all been very compartmentalized. So you have the front end automation, you have the back end automation, nothing's really connected. And the whole point of a smart factory is to be able to get your factory to the point where all these systems you have in place are connected. And why do we need to do that? Well, it all boils down to those who are able to react to the fast changing market conditions, able to win more business. If you're able to predict what your consumer is going to buy, and consumer, I think in many ways, getting more fickle, right? They want what they want when they want it. And the excuse of we can't deliver is not acceptable. So I think for anybody who wants to win more market shares or win the rat race, you don't have a choice but to get your factory, introduce the manufacturing intelligence that's required to allow you to adapt to market conditions. And secondly, I think what's happening with the global supply chain that we're seeing is that the old way of setting it to cheaper labor country and high volume ship into your local market, that's also going out the door. And there is we're not going back to a factory full of employees doing hand assemble or whatever the case may be. So again, adapting smart factoring, being able to link all that, especially with the labor shortage that we're seeing, really is the only solution forward. I don't think we have a choice. So if you want to be successful, you want to succeed, I don't think it's not adopting smart factory is an option anymore.
Great, thanks, Peng. So Paul, what would you add to the question, why is a smart factory important for manufacturing?
Sure. Look, I've I've been in this space for a long time. I've been blessed to be in the manufacturing space for a long time. And you know, I look at it a little bit differently. I think all the things that have been mentioned already are critically important, but I think about a smarter factory, right? In these operations, you know, there's disciplined teams, there's a lot of data being accumulated, there are a lot of systems, there's a lot of new visibility. It's about taking those tools and really moving them to the next level. And I think Peter covered off on some of that things when he talked about training people, right? You know, everybody, I don't know how good you can get in Excel. And if you want to get trained on Excel, you can do it online for free. But these teams have really run into a wall of productivity. If you look at the St. Louis Fed, they got a great website for economic data. They've got a chart where they show productivity moving very briskly, growing for decades. And for the last 11 years, 12 years, it has been flat to down. So we've added systems, we've added sensors, we've added data, we've integrated things. And I think we've missed the opportunity to engage these teams, these continuous improvement teams, and to hand them a new set of tools. And I picked up a little bit of that and was taking notes vigorously as Peter was walking through his slides, because you know, that's what he's talking about, is how do you get all these parts and pieces together? How do you create a new interaction for these teams that are ultimately going to drive the performance of these operations? So, you know, I think it's a smarter factory. I think this concept of a smarter factory is going to go from important to absolutely critical, because of all the disruptions that are coming down the pipe and how people need to look at these things. So we got to get them past this wall that they've bumped into and get some new tools in their hands, I think.
Great, thanks, Paul. So now we're going to I'll open it up. I want to make sure everybody got a chance here to kind of start with that fundamental question. So I'm going to open it up to the panelists and just ask the second question, which is, what are some examples of how you've seen or maybe experienced or deployed some smart technologies in manufacturers? Does anybody have any examples you could share? Yeah, go ahead, Paul.
Sorry, Peng. So first of all,
It's okay, Paul. I feel like it's one of those games where whoever can hit the sound faster.
I feel like I'm on Hollywood Squares. Nobody knows what that is if they're not my generation. Peng, would you like to start? Okay. So first, thanks to NGen and thanks to Salesforce for doing this. I was kind of, you know, ruminating a little bit on these questions this morning, and I shot a note to Peter, and it struck me as interesting that my impression of Salesforce and where Salesforce started was by being able to put tools in the hands of the artisan, the salesperson and their management team, and give them better visibility to data that they actually already had. I don't know that there was a lot of new data they got in there, but it was the ability to swipe a card and actually turn on a system that got them this better tool, this better ability to be productive. So I think if we look at where we are right now, a lot of these AI and machine learning initiatives tend to get bottlenecked at the top of an operation at the board level, where we're going to build. Peter's got great slides on this he didn't cover. Build a real foundation, spend 18 months, 24 months building the foundation. And then we try to build something on top of that pyramid foundation, and it may not match. So I'll give you a specific example. That's the point of this question, where we've seen this actually work. Is we're working with a tier 1 automotive company. They've got a well-deployed modern MES, manufacturing execution system. They've got controls and automation. They have a very complex process that does multiple steps. I think of these things as artwork when you watch these machines running. And they had come to us, they had a bottleneck. They said, we need to clear this bottleneck. We're really confounded by the data. There's so many different streams of data coming in, we can't analyze them all at the same time. And they said that we think we're missing data. We said, no, we'll take a look at the data that you have. We'll look at any new data. What we were able to discern, wring out of the existing data they had with zero preparation, was there was a fault that occurs that their MES is not tuned to trigger on, and that their controls and automation are not tuned to trigger on. So the machine learning engine in the background goes through, churns through all of these different sets of data as is, It's kind of acting like this continuous improvement mentor in the background. And it taps on the shoulder and it says, hey, pay attention, because when this occurs and this occurs, you have a negative consequence. And we start to see this trend occurring. Someone needs to pay attention. How that manifests itself with the team is now the team has taken data they already had. They thought they had fully exploited. And these are smart people. They're not lazy. They're not doing their job. They're working hard every day, trying to wring every dollar out of everything they have. The machine learning engine is pointing them in a direction. Then the CI team, the continuous improvement team, launches on that problem. They address the problem. Then they run that as a program launch across all of these similar operations. And then the machine learning engine is sitting in the background listening for some variation, some deviation from what they've now established as the new baseline. So data they had, systems they already had, zero bandwidth constraint from their engineering team, put it into the machine learning engine, pop these insights out, and people sit there and they say, okay, we need to go and check that. Yes, check, find these problems. Yes, these are issues. We need to make some changes to the control limits on this particular part of the process. We need to understand how MES works with automation. And in a matter of quite literally weeks, they had done an AI project that had a tactical, profound was the word their engineer used, impact on their operation. So think in terms of that. How quickly can you spin that flywheel up? How quickly can you get these learning turns, right? Just like inventory turns, learning turns, where people say, I think I understand what AI can do for me now in operations. If it could do that, why don't we go over here? Well, I don't really have the right data, or I don't have it collected in the historian. It points you to where to go next. And that's, to me, not trivial and very typical for the types of interactions that we've seen. So I think it's a great example. It's a great way for people to get started quickly. Thanks.
Thanks, Paul. And so Peng, you were second. So we'll let you share yours here as well.
Sure. I think for me, there's probably 3 examples that kind of define smart factory and kind of where it's going, right? It may not all be there yet. I think the first one talked about is I was in Brazil about 10 years ago and happened to be working with an agri company, a multinational agri company. And they were showing me, what John Deere was doing. And this is 10 years ago. And John Deere, as I said, is no longer a equipment company, if you can believe it, but more of an IT company, because they have all these infrastructure in place to monitor their equipment in farms, to track the number of seeds that are being planted and be able to give these really critical data back to the farmers, how their crops are doing, what's the water that they need. It's too complex for me to totally understand, but it goes back to this idea. If you take what they have done and apply to factory, it's a very similar idea. Is adapting all these different technologies, the equipment itself, the intelligence behind the equipment, the gathering of these data, and to be able to analyze these data to mean something to improve your operation or you improve your reaction to customers, whatever the case may be. So that's one example. The other example is a technology that my former company developed that ATS acquired called Symphony. And we basically, again, adopt technology to replace a lot of mechanical system. And that allows it to be extremely flexible, extremely agile. And you integrate that with smart factory technology. Again, it's just to be able to capture analytics that executive can look at to be able to react to their equipment before it becomes a problem, because you don't want to stop your production. That's very costly. And I think the third example, which relatively new technology, but very exciting, is out in the US. A entrepreneur is working on using Bitcoin as a background technology to develop, again, smart factory software analytic. And the reason the Bitcoin bit is important is because you don't want to lose the history, right? So now it's going further into making sure that that information is never lost. So when you start looking at all the different pieces that are being out there that are, that's happening and taking place, There's a lot happening. I think what's missing right now is how do companies pull it all together so that it is end-to-end integration. And again, going back to what I said earlier, from the factory floor to the front end to reacting to consumer, what Peter talked about with Salesforce. How do you pull all of that together? I think is the next big challenge.
Hey, Peng, sorry, can I ask you to expand on just that thought? You talk about this end to end and getting all this information available. Does it take an event, a bad event, for them to say, hey, now I get it? Or are they spending that money ahead of all the events occurring? Do they have a real defined ROI? Sorry, I hope you don't mind me jumping in there, but could you touch on that? You've got a pretty interesting purview on that.
Yeah, so Paul, I come from the back end, right? I've been in automation for 24 years and been very passionate about it, about this sector. I think the challenge, to be blunt, and I've said this, right? This whole idea of the industry 4.0, great concept, great idea, I'm all for it. But the problem is that unless there is a big enough organization or government mandated where it's forced all these different players to share the same IP protocol where all these are able to connect, I think is really, really challenging, because everybody does their own little pieces of the puzzle, right? So even when I see like L'Oreal in LinkedIn talked about working with IBM, and they call it their IoT, and they're all talking about how exciting this is for them. Well, that's great, but it's still just the front end. It's still just reacting to consumer. How do you connect that data then to, let's say, their automation equipment? And if you stay with your traditional automation equipment of very mechanical system, how do you react to these consumer demand that, I want a lipstick or whatever that is just my color? How do you create automation that can produce in that kind of volume? Bluntly, you cannot if you stay with the same old traditional, very mechanical system, right? You just can't. It's just a reality, because our labor force is it's harder to get technicians and engineers and all of that. But how do you change mechanical stuff that quickly? You have to go to machine shop, blah, blah, blah. And that's why this technology that ATS acquired called Symphony is so critical, because the mechanical cam is all replaced by digital cam. So you can actually change your robot motion on the HMI. You don't have to buy the 2-axis robot or the 6-axis robot. You have an N-axis robot. And so it's a decision that I think is harder for small business, because where do you start? I mean, that's another question we can touch on later. Harder for larger corporation, because hard also for large corporation, because unless the CEO has a vision of saying, this is where I'm going, all right, let's put together a team, end to end, what do we need to do? Everybody's operating in their own silo. So they're buying software, they're buying hardware, they're buying stuff that works for their silo, but it doesn't work for the entire organization. And bluntly, a lot of these decisions are long-term. So if you're operating quarter by quarter based on what you promise your shareholders and your share price, how do you make decisions that's going to be impactful 4 years, 5 years down the road, and not next quarter? Because these are not next quarter decisions. And so there are a lot of challenges regardless of how large your organizations are, because there are different challenges.
Great.
Makes sense.
Yeah. So thanks, Paul, for asking, Peng, and thanks, Peng, for that. I think that's really good, because the more you talk about shareholder value, the more you really get to the root of this, because in some situations there is a cost associated with this, and there needs to be value produced. Craig, so same question for you. What are some examples of how you've seen or experienced or deployed smart factory technologies?
Yeah, thanks. Yeah, I'll give a few examples. And I really like Paul's framing of the opportunity. How do you make a smart factory smarter? If you want to Google Forbes and PepsiCo machine learning, you'll see an article there with some great examples. And one of them is taking lasers, which might have traditionally been used to detect product quality and a simple no-go, is to integrate machine learning into that process to perform better quality checks and to move away from a simple like go, no go. From Pinevo's perspective, working with NGen and on our project, which is currently underway, we've developed a real-time lean manufacturing platform where we'll deploy sensors at a facility or take existing data from the PLC network. We'll implement IoT gateways, low-cost gateways. So it's a low-cost solution to collect and aggregate existing data. We'll send that to the Microsoft Azure cloud in Canada, and then it's sending back data to operators on tablets or HMIs or PCs at the facility, virtually in real time. The delay to the cloud and back is like 1 second or so, plus perhaps a second for the firewall. So that ability to use the cloud to make true real-time decisions is here. And you know, this is early days for us. We've been live for a year or so with this system. We are already processing over 10 million messages a day. So you can see how this is going to scale, and to put servers locally at a facility and to maintain them to do this kind of service across multiple facilities. Yes, you could do some edge computing, but the cloud is a great solution to this. So we're at the stage where we can report and understand overall equipment effectiveness in real time, and we're looking at integrating machine learning for use cases such as production scheduling, for example. How can that be optimized? The data sets are just too big. When you've got tens of thousands of product SKUs, you just can't do that. So machine learning is a great use case for that. And we're also utilizing machine learning to help optimize utility performance at facilities. So services at facilities like refrigeration systems, compressed air, steam boilers, etc., through traditional energy conservation measures and energy management systems, you might be able to yield cost and utility and carbon emission savings of 8 to 90% of like global best practice. Machine learning comes in to squeeze out that last few percent. What we've not been able to do thus far is understand how we integrate blockchain into our business model. But if any of the panelists have got any smart ideas for that, I'm all ears. Thanks.
Thanks, Craig. I was thinking as you shared how many messages per day are being captured, the first thing I thought of is maybe this is a good tool to manage my inbox. So we're going to ask the same question now just relative to your own examples, if you will, Peter, that you've experienced where smart technologies are being deployed.
Well, I've never seen a more inspiring customer story than the one from Tuff Shed. That's TUFF. They make backyard storage buildings, and you might have seen them at a Home Depot or a Lowe's or some such place. They turned their model inside out from making a variety of standardized buildings in certain sizes and so on, to doing an online configuration tool where customers can come in, pick out different elements, put together a bespoke design, and purchase it at a price competitive with the standardized buildings. You don't get that by adding automation to your existing silos. You get that by saying, wait a minute, we're going to invent a different customer experience. We're going to do what Alvin Toffler literally was writing about 50 years ago in Future Shock when he used the expression mass production in quantity one in one of the most low-tech products you can imagine, and create a completely differentiated idea where instead of competing on price and quality with other standardized offerings, they were able to become genuinely unique in the mind of the customer. But crucially, that story begins with one change leader at Tuff Shed writing a letter to the CEO saying, this is my date left off resignation. I want the opportunity to do this. If it doesn't work, fire me. Someone took the initiative to say, I want to turn everything we do inside out, change our criteria for what we optimize for, from producing our product line at minimum cost to changing the definition of what we sell. And that's what it takes to get people out of the detent. Peng mentioned L'Oreal. L'Oreal, you know how cosmetics are sold. You've got the counter at the department store where people come in and try on the different shades. During the pandemic, they went to a completely online tool for being able to try on different shades on pictures of yourself that they estimate they got done in 8 weeks, when without the acceleration of the pandemic, their own estimate is that it would have taken them 3 years to get that done. So the accelerations of the pandemic are real. The definition of a different customer experience driving a recombination of your existing silos rather than an improvement of their individual performance, as Peng was saying, is absolutely key. And Paul, you talked about the fragmentation of data. Our own estimate is that in the pre-Salesforce era, and working with Deloitte on this, they came up with this number. The typical company, if it really wanted to know everything it's ever done or has ever hoped to do or is currently doing with any given customer, would literally need to look in over 36 places. There'd be an email thread here, a marketing campaign response there, a spreadsheet over there, an ERP record over here, and so on. Bringing that all together into one view of the customer with different facets of that relationship visible where they need to be for design, for production, for distribution, for after-sale service, recognizing pandemic acceleration and beginning the question with what's the unique experience we want to offer to our team and our customer, not what's the lubrication we can put into the gears of our existing machine, is how that happens. And it's why the label of smart factory does mean more. And I think Peng and Craig have both been emphasizing this. It means so much more than adding better technology to the current status quo model, but visualizing the opportunity for a genuinely different model.
Great, thanks. Appreciate that, Peter. So the next question, I'm going to take the second part of the next question. I know everybody prepared, but I think it's important. Let's talk for a minute about pitfalls. Now, I know we're talking about a very broad topic, and it's kind of hard to just jump on specific pitfalls. But I guess the question is, if you were a manufacturer today and you're considering, you want to move towards a smart factory, you want to, talk, we've discussed different ways and means by which we'll introduce this technology. What are some things you would suggest that manufacturers need to be aware of? Some potential pitfalls, some areas where they might fall down that you could give them some tips or strategies to avoid, whether it be a delay or a costly mistake that they might make. And if you have an example to tie in with that, even better. So I'll ask, because I changed the question slightly. Is there somebody that wants to start with that? Peng, go ahead.
Yeah, so I think I'm going to use my own personal experience because that's safe. It's me. Thinking back when I was CEO of Transformix, and as we were trying to adopt technology, and in this particular case was ERP, we were still a small company, and thinking back, probably the greatest pitfall we had was not appreciating the deep learning curve that our whole team had to go through, and the hidden cost of having to bring their company expert in all the time. And that far exceeded the actual hardware cost. So I think that would be my cautionary tale to companies that are looking to adopt different technology to try to bring all the different pieces of the puzzles together to be able to build a smart factory. Is you got to be more forward thinking in terms of how do the different technology you want to adopt going to integrate together. Do you have the resources? What's the training program? Is this something that is user-friendly, or is it a constant having to bring in their expert because it's so unique to them? And even though we actually spent probably a year analyzing all the different software out there, in hindsight, that would probably be the most challenging, was the how long it took to adopt.
Okay, appreciate that, Peng. Craig, you had raised your hand there. What have you found, or what would you suggest? What are pitfalls or things to be aware of?
Yeah, again, I think I'll revert to Paul's making a smart factory smarter, because if you've not got the infrastructure in place to support some of these initiatives we've talked about, and you've got the management buy-in, it's just not going to go anywhere, and you're not going to get the benefits of it either. So looking at the process of big data, machine learning, making decisions based on that. So how do you get the data out of a facility? Well, if you've not got a sound infrastructure in place and a sound like network, PLC network, historian, if that's where you're storing the data, gateway to get the data off the facility, wireless network, etc. If you've not got that in place, the data is going to fall down. That's feeding into those models, into that decision making, and then just taking big data and pointing machine learning at it is not the way to go. Have we got data integrity? That's the first question. Can you guarantee what you're getting is sound? And that might be, erroneous data might be, it's just plain wrong. It's the tolerance aren't good enough. There's data dropout, etc., which feeds back into the network issue. So you've got to before you start machine learning, for example, is making sure that the data set is sound, but also really well defining the problem and what you want to get out of it. So it might be that you can generate the majority of savings by optimized process control, for example. So you don't need an AI algorithm to tell you to turn a valve into a particular way. And then finally, I'd say you're going to get out of it what you put in. Again, having the management buy-in top down and engaging operators and everybody across the business is certainly where to go to ensure success.
Great. Thanks, Craig. Paul, what are your perspectives on potential pitfalls?
So I'm sitting here trying to think about how to politely indicate that I'm going to be a contrarian here, right? I think this is a tribute to Salesforce and NGen for bringing together people with some different views. Look, if you're altering your interaction with a customer and you're going to make a single tube of lipstick and that's going to come through and be manufactured and shipped on the same day, that's I think one aspect of the issue. Peter talked about Go being a 170 and sailing being a 2900. I've been in manufacturing long enough. It's got to be maybe an order of magnitude more than that, because you have the plan and then the doors open and you get punched in the face. And it used to just be it's snowed or it's deer season or something, and now it snowed, it's deer season, and we just tested positive at the front gate, and somebody slipped through that wasn't tested, and now we've got all of this other stuff. So we create this complexity, and where I see the pitfalls. And remember, I had the real pleasure of working at one of the largest industrials, CIO for advanced manufacturing strategy. I think I mentioned that. There's a lot of people who tend to think you can kick the door open to the plant and say, hey, pay attention. We're here to transform you. We're going to make things better. I know this. I've got a XYZ MBA, and I'm glad, and it's logical. There's training, there's an understanding of a business model you're trying to deploy. But what they generally miss is that if I don't have an unruly team, if I have an unruly team and bad management, there's nothing here to do for you. Get your team squared away, get better managers. If you've got some level of discipline, if you're shipping parts into an automotive supply chain, you have discipline, you have rigor, you have processes. They may not be perfect, they may not be all aligned. I think, and we've bet on the fact that you can take those pockets of the lowest level data. And I think Craig, this is where you're heading a little bit. If what you have to do is harmonize all that data, it's going to take you forever to get one little pocket of data that you can run machine learning against. Our approach is to say, leave it as it is, where it is, vacuum up whatever you got. Maybe it's on a thumb drive, maybe it's on a wire, before we start this transformation, because now we're going to point you to what process needs to be impacted, what area needs to be affected. And I think the pitfall that I see is, you know, I'm not going to tell you who they were, but I mean, they're really smart people and they're great industry analysts. And it was a webinar I was on, and they said, well, first you have to do a readiness assessment across your whole company. And then once you've got that, you've got to pick the problem you're going to solve. And then you've got to harmonize all the data. And all you've done is you've built bias into a system. You've embedded it that you're never going to get out. If you know the machine's running and I'm shipping product and I know what good product looks like, I should be able to exploit that data instantly. The tools are not widely available to do that. That's where we've had our head down doing those things. And when I popped my head up the other day and just jumped on this webinar and I'm listening to it and I'm hearing, man, we talked about this in 2005 when I was at Lighthammer going to SAP. We're having the same conversation. Then I look at the Fred chart and I go, I kind of get why we're flat, right? We got to take a little bit of different thinking. So the pitfall is to make the leap that the teams are not equipped, that the teams aren't capable of doing something if we could equip them with a little better tool. What if we do a little experiment? What if we salt in a little bit of technology, not technology like a new machine or a new system, but a way to analyze and kind of wring out value from this data? That's our argument. And then you know what step to take next. Is it this direction to add more sensing? Is it this direction to add more connectivity? Is it this direction to actually just scrap the line because you just don't have the capability to run that line in a particular fashion? So it's a great risk that I say that one of the pitfalls is listening too much to the experts on the webinars and not the experts in the plant, and say, what is it that you're missing? What tool do you need? If I could grind up that data and pop out some insights, tap you on the shoulder, could you do something with it? Do you have enough discipline and rigor in your process and system to do it? Because we've seen time after time that that's capable. Now, that doesn't diminish what Craig's talking about, which is the ability to get that data and actually make it easier to run through that data, because that's going to be a critical step, maybe the first step if you have nothing. And what Peng's talking about, which is a better process. I saw the Symphony stuff. I mean, it looks incredible. The ability to say, send a signal and say, here's how I want you to manufacture that, and have a system reconfigure itself. But those are, you know, are they on the edge of the curve, right? And most everybody else is kind of, I'm still running a process that I need to be able to make better every given day. So you're smart. So one comment I'll leave you with. Jeff Immelt said this. We're in a small meeting, and he said, look, just remember that whenever you hear the experts writing or blogging or talking, you're probably as smart as they are on the topic that you spend your day focused on. Don't necessarily drift off and just take what people are saying. Find ways to do really quick, low risk experiments that let you, again, spin the flywheel of continuous improvement up, those learning turns, and that are going to actually impact the process. So that, I think, is a pitfall, is if we say, yep, the plant isn't going to do anything, we're going to wait for another 18 months until the foundation is built so that we know what tools and technology I'll be able to access and drive. I have to do something tomorrow. I mean, I've got to make this place run better the next shift. So don't lose the focus on what's going on right in front of you. If that makes sense.
Great. Thanks, Paul. Appreciate that. Peter, your perspective on kind of some potential pitfalls to be aware of?
Yeah, if I could offer the shortest possible versions of two stories from two different domains. When I was at Baton Rouge chemical plant, and we were working with some machinery that handled, a form of rubber that had a tendency to break down during production and leave this stuff that we technically called a goo all over some of the rotating equipment. One of the ways to clean the equipment is to run ice through it, which made the rubber, get hard and then kind of flake off. So having an ice machine next to the extruder was something you needed to do when we were building the new one. And I was in a meeting once where someone was saying, yeah, well, we've got the specification for the ice machine almost ready to go out for bid. And one of the guys just blew up and said, it's an ice machine. They have one next to the elevator in every Holiday Inn. What are you doing writing a spec for it? You buy this out of a catalog. And the lesson to be shared is, we're in a world now of interoperable services, cloud capabilities, repurposable components. The tendency to do this the way we've done this before, of thinking we need to do an elaborate bespoke solution, when in many cases, composing things out of readily available and highly configurable services is a novel approach. And doing it the old way as well as it can be done is doing, in fact, the wrong thing. The other story is from oil and gas field services, where we were talking with someone who said, you know, one of the problems is people keep wanting to say, and now we can put the equivalent of a laboratory analyzer at every wellhead, and we know exactly what chemicals are coming out of the ground. And the guy raised his hand and said, at the beginning of the day, I got a guy in a pickup truck. And the question is, out of the 10 square mile area for which he's responsible, should he go north, south, east, or west to get the maximum amount of work done that morning? All he really needs is red light, green light. Is the pump pumping or is it not pumping? Because that's what's going to really control where his time goes. And that, I think, speaks to the point that's already been made of get as close to the front line as you can and find out what relatively small number of pieces of data delivered reliably in a timely way and an understandable way will have the maximum effect on getting actual work done, instead of allowing people to get really excited about all the bells and whistles that they could conceivably inject into their quote smart factory unquote.
Great. Thank you, Peter. Appreciate that. So we're going to move into the last question and then open up for some Q&A. We do have a couple of questions that have come in here, but before we do so, and based on our time, I'm going to term this the rapid fire response, okay? Because I want to give everybody a chance for kind of some final thoughts here. So the question is, if you were sitting in front of, let's say, which you are, some manufacturers, and maybe they're struggling with where should they begin? If they're trying to create a strategy relative to their smart factory or developing a smart factory, what are some tips or ideas you would share with them as a good starting point? And I'll just start, well, let me start with, I'll just work around if that's okay. I'll end on you, Peter, so Peng, what are your thoughts?
I would say just start on whatever it is to help your employees do their job quicker, faster, and be able to adapt to customer demand.
Great. Paul.
So I have a really complicated, long-winded transformation strategy. It's start in a corner and have a little better hors d'oeuvres and music and get people excited about the one thing that you did that was impactful, and other people will peel off from every other party and join yours. And it creates a viral effect. Done it, I've seen it, it works every time. So while you have a grand vision, you have to have the value that's delivered from that vision, but start at the tactic, start at a single spot, fix that. And you want to get people excited and drive things, that's a great way to go.
Great, thanks, Paul. Craig.
Yeah, I'm fully on board with start small and scale it from there once you've validated it and created that excitement. So to do that, you can actually lean on suppliers a lot. So for example, asking for free trials, like, yeah, great technology, come here and prove it, and then away we go across the entire facility and the entire business if that goes well. So I think one of the barriers to making a start is like actually understanding the business case. You know, how much money am I going to save? Sometimes that's super difficult to kind of get over that. So doing that free trial and having the supplier having some skin in the game is a great way to go about that, to validate that. And another way is to get funding. So across Canada, provincially and federally, there's lots of funding that can be accessed to support that initial engagement. So for example, Canadian Manufacturing Exporters, CME, they've got their technology assessment program in BC, where you can do a free lean manufacturing audit of the facility, which can help frame some of these issues potentially. In Saskatchewan, there's the Lean Improvements in Manufacturing program, where the Saskatchewan government will fund up to $500,000 at 50% for process optimization initiatives. So there's some great funding out there. That's just a couple of examples that you can access to get up and running on this.
Great, thanks, Craig. So Peter, I know you had your hand up earlier there. So
oh yeah,
your perspective.
Walk around with a camera and take a picture of every place that you see someone taking their eyes off their work to handle a terminal or do something in a spreadsheet or do something else, and say, how do we make that a connected data flow in which the data flows in without someone having to manually, take their eyes off of what they're doing to enter something on a keyboard. The device itself should be measuring that data and reporting it in a timely, accurate, consistent way. And the actions to be taken should be delivered as close as possible to the point of that action. And every time you take out one of those interface layers, you're taking out a failure mode, you're taking out a training requirement, you're taking out a frictional barrier to adoption.
Great. Thanks, Peter. Appreciate that. All right. So we do have a couple of questions that have come in. So what I'm going to do is just ask the panel. I'll open it up. So first person to hit first person to hit the button, I guess, or raise their hand, it'll go to you. So we'll start with this. How are manufacturers finding the right collaborators to share and accelerate their Industry 4.0 capabilities? I'll repeat that again. How are manufacturers finding the right collaborators, or else even add the right partners, to share and accelerate their capabilities, specifically in the areas we're talking about? And Craig, you kind of touched on this too, right? You can get free trials. Are there areas you'd suggest companies start with? Peng, sorry, if somebody else did raise their hand, I'm sorry, I saw
So
Peng.
Peter actually had his hand first, so I'm happy.
Okay.
to
I was just going to say, the more frontline workers you bring into the room and the more they actually feel like what they say is going to matter. We saw this happen at Delta Airlines, for example, where they brought the cabin crews into the room to say, this is what needs to be on the smart device that's going to help us deliver that better customer experience. The more they're in the room and being heard, the more likely you are to have not only the right thing being built, but a more rapid adoption of it once it has been built.
Thanks, Peter. Peng, did you want to?
Yeah, I think what Peter said with respect to bringing key employees from each division to figure out what is it that your organization needs. But outside of that, I would suggest maybe to form your own, support team of other executive from other organizations. I've done that in my past life when as a CEO that was, relatively young to the game, and I had a CEO club where it's just half a dozen of us that we meet regularly to talk about specific issues. So you could form your own, sort of smart factory clustered of other executives and share ideas that way as well to learn from each other's mistakes.
Craig, did you have any thoughts on that?
Yeah, I'm surprised you didn't want to answer that, Sean. I would have thought the ideal answer was to ask NGen, become an NGen member and leverage the NGen network.
We would love that, but I didn't want to lead with that. No.
So I think that's as good an answer as any. I'll leave it at that.
Okay. Well, and as an NGen member and somebody who's gotten involved, you can speak to that from experience. So thank you for that comment. Paul, any thoughts on that question yourself?
Yeah, look, it's same thing. NGen, I mean, there's some good groups out there. There's some good events, but people are going to suffer from information overload, buzzword overload. Put people on the bubble. Find somebody, tell them you want to talk to them for 15 minutes, and then hit the buzzer and throw them off the phone if they don't understand operations, if they don't understand the challenges. I mean, you need to dig around a little bit. And it would be great if there were better ways for manufacturers to find them. But if you see a story that resonates, if you see a vendor that resonates with the types of problems you have, reach out. And like I said, but time limit it, right? Don't lose half your day taking a sales pitch from somebody. If they can't get to it in 15 minutes, pitch them.
Yeah, that's great. Appreciate that, Paul. All right. So what I want to do, the last question here was very similar to that. It was, finding people that can assist you in moving forward with your journey. And I think we've kind of addressed that here. I mean, it really depends on what journey you're taking. Obviously, and NGen and a variety of other organizations and associations who are plugged in are a great place to start, because you can connect with smart folks like the panelists we have here today who can help you along the way and give insights and in some cases actually assist. So I'll leave those questions. I think we've answered those to the extent necessary. So what I want to do, just based on our time here, I want to give yourself, Peter, give us some closing thoughts based on what you've heard here today, what you were our keynote. So I want to turn it over to you for the next 5 minutes or so, just to share some thoughts and ideas.
Well, if I can go back to one of the things that Craig was talking about, which is kind of thinking of the sequence of accumulation. It hasn't been a succession of technologies in the industrial revolutions. It's been an accumulation. We made power scalable with steam. We made it distributable with electricity. We made it intelligent with electronics and automation. And now we're making it guided and focused with introduction of AI. These are cumulative revolutions, and smart manufacturing uses all of them effectively. But if you took that original 19th century first industrial revolution factory with the shafts overhead and the pulleys and the belts and everything driven by one massive steam engine, and you unplugged that steam engine and put in an electric motor, wow, cleaner, quieter, cheaper. Everyone would say what a great success it was. And yet the basic architecture of the factory would still be those overhead shafts and pulleys and all the machines going on and off and running at the same speed during exactly the same hours of the day. You wouldn't really have gotten what electricity could give you. You'd only have used electricity to do the old things somewhat better. And Eric Brynjolfsson at MIT and Lauren Hitt at Penn asked, is the same thing true for IT? And they did a really thorough study of dozens and dozens of companies that, you know, the companies that reorganize to use the new capability to do things in a different way produce hugely better results than the ones who merely introduce the technology to do the things they've been doing, but to do those somewhat more cheaply and efficiently. And so the first line of the first slide I shared today about beyond efficiency is so key. You have to be prepared to look at what you do through different eyes of, given this capability, how would we have visualized what it is we do here? And then the other thing I want to add is there's a tendency to think of the labor component and the technology component as both being ingredients that get pulled in and the customer is someone outside. The idea that the people who work for you are a customer, that you are selling them the package of pay and benefits, and they're paying for it literally with the best years of their lives, and you're competing for that customer who could take the best years of their lives and go spend them somewhere else. That's a completely different way of thinking about what we're trying to do when we create a work environment that makes people feel engaged, that appeals to their sense of being of mastery, that people get actual pleasure from doing things well and knowing they're doing them well, and creating the factory as an environment where people feel empowered and enriched, so that they will in turn give you their best insight and be eager to say, you know, we could be doing this differently, and not feel that they're going to be smacked down. This really ties a lot of this together. So smart factories include, and I think this is very much in line with what Paul and Peng have both been saying, is that smart factories include and totally depend on smart leadership and not aggressive, vigorous adoption of technology to do the old thing better. And if we take that away and say, what could I do tomorrow without new headcount, without new capital budget, without permission from anyone? A simple question of, who don't I talk to? Who don't I listen to? What assumptions am I making every day without even thinking of them as being assumptions? Those are all things that we can do on an individual level. And the sum of those things creates amazing organizations that redefine their industries.
Great. Thanks very much, Peter. So I want to take the last few minutes here, since we have a few minutes, and maybe this is a surprise to the panelists, but thinking maybe give you a minute if you want to say some closing comments. And before we do that, and then I'll thank everybody, but I do want to take a moment, obviously, to thank all of our panelists here. So first off, obviously, thank you, Peter, for your presentation today. It was great. Shared a lot of great insights. Thank you to Craig, Paul, and Peng for your time. I know you're all extremely busy. So on behalf of everybody that's joined us here today, as well as NGen, I want to thank you for your time. So just some closing, brief, obviously, some closing thoughts from today's discussion. Paul?
Yeah, sure. So look, you know, you can assign this to the shameless plug category, right? We're an organization that takes that operational data as is, as it exists in the operation, wrings additional value from it, and then uses it to drive this acceleration of continuous improvement. And you know, we've not worked with any company that doesn't have enough data, doesn't have reasonably disciplined data that can drive it, and it helps create, like I said, that small initiative that has the opportunity to go viral. Just today, one of our customers that we were working this process with, we got an email that said, we've had a very significant issue occur. Would you have been able to determine this? And the answer is yes. And now everybody's scratching their head saying, geez, I wish we would have gone faster. So this goes back to the start now, start small, start fast. My saying is, do something that's small enough that that's large enough that if it's valuable, it's going to have an impact, and small enough that if it doesn't work, we can all bury it out back and get to keep our jobs. And if you think that way, and if you think that you've got some issues, I mean, this is an exciting time for manufacturers. So, and thanks again to the panel, and thanks again to Salesforce and NGen for allowing me to join.
Thanks, Paul. Peng, some closing comments in the next minute or so?
Sure. Yeah. So following up on Paul, thank you, NGen, for inviting me, and the audience for showing up. I don't know how much more to add to what Peter and Paul said, other than, maybe because of my entrepreneurial background and created an R&D company, is no matter where you start, the next time you do it, you're going to learn from that, and you're going to be that much better. So get started. And I think, Peter touched on a really important point. There can be no changes until leadership's willing to take chance. There can be no innovations until leadership's willing to say, you know what, we may fail, and we're not going to punish those who fail. I used to say jokingly, but kind of serious, to my staff, when you make the first mistakes, what did you learn? Because it's going to make us that much better the next time, right? That's innovation. That's anything you want to do. If you make the same mistake twice, either you're an idiot or I'm an idiot. So let's not make either of us an idiot. So let's learn from that. So whatever it is that you chose to do, whatever pieces of your entire business, depending on where you are in your journey and the size of your organization, pick something that is going to be impactful, that, no matter what it is, you're going to be one step ahead. Even if you had planned for 5 steps and you gain 1, you're still further ahead. So just start on the journey.
Great. Thanks, Peng. And we've got about a minute and a half or so here. Craig, final or closing thoughts?
Yeah, thanks. I'm going to actually go back and answer one of the previous questions that didn't kind of get covered, and that's what success have you experienced? So a large sector focus for Benevo is the food and bev sector. And a lot of the food and bev sector is actually operating at Factory 2.0. So our challenge or the opportunity for Canadian manufacturing is how to transition food processes from 2.0 to 3.0 to 4.0. So if you're, for example, a blow molding facility, you might have an OEE score, overall equipment effectiveness, at like 99% or something. You're tweaking that last 0.1, 0.2 to squeeze out that last bit of performance. If you're a Factory 2.0 food and bev processor, your OEE might be 50%. So you can, by implementing lean manufacturing principles and starting that transition right up to Factory 4.0, you can expect double-digit percentage savings. So there's just a phenomenal prize there for Canadian manufacturing, in particular the food and bev space that we're operating in. It'd be great to support Canadian manufacturers with that journey.
Great. Well, thanks, Craig. So, and Peter, I'm assuming we're kind of good with, unless you have anything else to add, you're good. Perfect. Well, listen, once again, I want to thank our panelists today, Paul, Peng, Craig, Peter. I really appreciate your time. We appreciate all of you for joining us. This recording will be made available to anybody who couldn't join us. And I want to wish everybody a great rest of your day. We'll see you again next time. Take care, everybody.
Thank you.
Thanks, everyone. All the best.